Dear students, let me introduce myself. I am Dr. M. Sabariswaran, Professor of Mechanical Engineering Department, SSM Institute of Engineering and Technology, Thindikkal. Now, I welcome you all to this course on robotics. To start with the subject, let us start with the definition of robot. Let we define robot. It is an automatic machine which is reprogrammable and multifunctional. Nowadays, the robots are available in different forms. For example, the robots are available in the form of manipulator. The manipulator means it is a robot with a fixed base. The robots are also available with moving base, just like the wheel robots, multi-legged robots. Now, the multi-legged robots could be either two-legged robots, four-legged robots, six-legged robots, and so on. And tracked vehicle. And nowadays, the drones are very popular, and drone also a special type of robot. Now, to study this particular subject, robotics, actually we will have to study 5 units. The first one is fundamentals of robot, and unit 2 robot drive systems and end effectors. Unit 3 sensors and machine vision. Unit 4 robot kinematics and robot programming. Unit 5 implementation and robot economics. The textbooks of robotics, that is Industrial Robotics Technology Programming and Applications by Groover, and Robotic Engineering and Integrated Approach by Clafter. Now, let me start with what is a robot. The term robot has come from the Czech word robota, which means the forced or the slave laborer. So, this is just like a servant, and we are going to give some tasks to the robot, and it is going to perform those tasks just like a servant. Now, the term robot was introduced in the year 1921 by Karel Čapek. Karel Čapek was a Czech playwright, used the term robot first in his drama named Rossum's Universal Robots. So, in this drama, the way he described a robot is as follows. The robot is a machine but look-wise similar to a human being. But nowadays, we use a few robots which do not look like the human being. So, this is the way actually the term robot was introduced in the year 1921. But during the time, there was not even a single robot in the world. Now, if you see the history, the term robot has been defined in a number of ways. For example, according to Oxford English Dictionary, a robot has been defined as a machine capable of carrying out a complex series of actions automatically, especially one programmable by computer. So, this is nothing but an automatic machine. Then, according to the International Organization for Standardization, has been defined, the robot is an automatically controlled, reprogrammable, multi-purpose manipulator, programmable in 3 or more axes, which can be either fixed in place or mobile for use in industrial automation applications. So now, as I mentioned, that the robot is nothing but an automatically controlled machine, and it is reprogrammable. That means the same robot can perform a variety of tasks, and to perform variety of tasks we will have to change its program, and it is multifunctional. That means the same robot, the same manipulator can perform the different types of machining operations. It can do some sort of pick and place operations, welding operations, painting operations. So in this definition, we are using the term manipulator. So manipulator is nothing but a robot with a fixed base. So now this manipulator would be either serial manipulator or parallel manipulator. Now another very popular definition is given by RIA, that is Robot Institute of America. So now they defined robot as follows. It is a reprogrammable multifunctional manipulator designed to move materials, parts, tools, or specialized devices through variable programmed motions for the performance of variety of tasks. For example, by manipulator we mean robot with fixed base, and that is nothing but a mechanical hand. That means the human hand we are going to model, design, and develop in the form of an artificial hand, and there is nothing but the manipulator, and it is reprogrammable and multifunctional. Now, in terms of reprogrammability, if we compare a robot with the NC or CNC machine, so now in CNC machine, like computerized numerical control machine, we can perform a variety of tasks by changing the program. Similarly, in robots, the same robot I can use to serve a variety of purposes simply by changing the program. But here there is a basic difference between the level of reprogrammability which can be achieved by the robot and that can be achieved by a CNC machine. Now it is important to note that the level of reprogrammability which can be achieved by a robot is more compared to that CNC machine, and that is why CNC machine is not a robot. Hence CNC machine is actually not a robot. So next I am just going to define what is meant by the robotics. Now the robotics is a science which deals with the issues related to design, manufacturing, development, and application of robots to perform a variety of tasks. The term robotics was actually coined by Isaac Asimov in the year 1942. Isaac Asimov wrote one story. The name of the story was Runaround, and in that particular story he used the term robotics first. But once again, let me mention that during that time, that is during 1942, there was not even a single robot in this world. Now here in robotics we use the fundamentals of different subjects. For example, physics, mathematics, mechanical engineering, electronics engineering, electrical and electronics engineering, computer science engineering, and others. And that is why it is bit difficult to become a true roboticist, because if you want to become an expert, a true expert of robotics, we will have to know the fundamentals of all these basic subjects, and a robotics is actually a multidisciplinary subject. Next, what is the motivation behind robotics? Why should we study robotics? What is the reason? If you see today's market, it is dynamic and competitive, and if you want to be in competition and if you want to be in business, what you will have to do? You will have to fulfill at least three requirements. First one is reduced production cost and increased productivity, and finally improved product quality. So first you will have to produce good at low cost, and at the same time the productivity has to be high. and the quality of the product has to be good. So now you see the three objectives like reduced production cost, increased productivity, and improved product quality. So now it is bit difficult to achieve all these three things at a time, and some of them are actually conflicting. So now if you want to achieve all three, there is only one solution, and there is nothing but automation. So you will have to go for automation if you want to achieve all the three requirements. Now if I proceed further, let me tell you something regarding the different types of products and methods which we generally use. Now if you see the production methods, the purpose of production is actually convert the raw materials into the finished product. Now these production methods could be of three types. For example, you can have the piece production, then there would be a batch production, and there would be a mass production. Now for piece production, we have got several designs, and each design we will have to manufacture small in number. Now for batch production, we have got a few design, and each design we produce a few in numbers. Now in mass production, we have got only one design, and that particular product is to be produced a large number. Now we can automate this particular batch production, mass production, and of course for piece production, automation is not possible. So there is no automation for this particular piece production. But for batch production, we can go for automation. And for mass production, we go for automation. For mass production, we generally go for the fixed automation or hard automation. For this particular batch production, we generally go for the flexible automation. Now, the robotics is an example for the flexible automation, and that is why for batch production, particularly in manufacturing unit, we will have to go for the robots if you want to survive in this competitive market, and that is why the robotics and the robots have become so much popular in manufacturing units. But nowadays, not only in manufacturing units, the robots are used in different areas. For example, the robots are nowadays used in space science, used in medical science. Robots are also used for seabed mining, in agriculture, firefighting, and so on. So there are various applications of robots nowadays. Now here all such things I have noted. Automation can help to fulfill the requirements of the above requirements. And robotics is an example of the flexible automation, and that is why we should study robotics. So now I am going to concentrate on a brief history of robotics. Now if you see the NC machine, that is the numerical controlled machine, that was developed first in the year 1950, but robot came after that. So the first robot which was developed in the year 1954. So in 1954, the first patent on the manipulator was filed by George Devil, and he is known as the father of the robot. In 1956, Joseph Engelberger started the first robotics company, and the name of the company is Unimation. So Unimation is the first robotics company which was started in the year 1956. Then in the year 1962, General Motors used the manipulator. The name of the manipulator is Unimate, and this particular robot was used in die casting application. So in this video, so you can see the father of the robot George Devil and the company Unimation.
Patented the concept of the robot and the technology associated with it in 1954. Which is the very first one that was used.
This is the Unimate robot showing off its moves back in 1967. By then, it had already been on the job for several years.
The Unimate.
Has the Unimate been properly acknowledged and celebrated?
Oh, it's...
As well they should, because for industrial robots, the Unimate is the granddaddy of them all.
Patented the...
So next, in the year 1967, General Electric Corporation made a four-legged robot, and this is a four-legged vehicle, and they demonstrated and it worked well. In the year 1969, SAM was built by NASA, United States of America. SAM was the name of the particular robot which was built by the NASA. Then Shaki, an intelligent robot, was actually manufactured by Stanford Research Institute, SRI. In fact, Shaki is the first intelligent mobile robot that was developed in the year 1969. In 1970, Victor Steinman demonstrated a manipulator known as Stanford Arm, and the Lunokhod 1 was another robot that was sent to the moon by USSR. Then Vodex 1, another robot, was built by Vodactix in the year 1970. So this video shows a four-legged vehicle. Next, Shaki, an intelligent mobile robot. Next video, Lunokhod 1. The next video, Vodex 1.
One of the most revolutionary six-legged robots ever made is Odex 1. Built in 1983 by Steve Bartlett, it was years ahead of its time. The robot gets around by moving 3 legs at a time and maintains its balance by keeping the other 3 legs firmly on the ground. This is known as static balance.
A static leg system is one that when he stops, or for that matter when he's in motion, he always has at least 3 feet on the ground at one time with the center of gravity somewhere within that pattern. So he doesn't have to actively balance himself. He's always stable. And when he comes to a stop, he's...
Next, in the year 1973, Richard Hahn of Cincinnati Milacron Corporation manufactured one robot. The name of the robot was T-3, that is the Tomorrow Tool robot. Then in the year 1975, Raybert at Carnegie Mellon University, USA built one-legged hopping machine, the first dynamically stable machine. In 1978, Unimation developed Puma, that is Programmable Universal Machine for Assembly, and this is actually a manipulator whose current version is having 6 degrees of freedom, and it is very frequently used in various industries. So the video for Programmable Universal Machine for Assembly. Next, in the year 1983, Vodactix, a robotics company, introduced a unique experimental 6-legged device. In the year 1986, Adaptive Suspension Vehicle, in short ASV, was developed by Ohio State University, USA. In 1997, NASA USA developed the intelligent robots like Pathfinder and Sojourner, and they sent them to the Mars. But that particular mission was a failure, and that particular failure was due to some sorts of mismatch of the specifications. So ASV. It's a 6-legged device. Next, in the year 2000, Honda would develop one humanoid robot, Asimo robot. Then comes in 2004, the surface of the Mars was explored by a Spirit and Opportunity, and this particular mission was successful. And you might be knowing what happened in 2012. The Curiosity, one intelligent autonomous robot, was sent to the Mars by the NASA, USA, and this particular mission was successful. Then all of you might be knowing what happened in the year 2015. Sophia, that is one intelligent and a little bit emotional humanoid robot, was built by Hanson Robotics, Hong Kong, and this is actually, as on today, the most sophisticated intelligent humanoid robot. And a few weeks ago, this particular robot was brought to IIT Bombay, and there she would talk, she would communicate with other people, and some of you might have seen in paper or a television. So that particular very sophisticated intelligent humanoid robot is Sophia. So these are in short the brief history of the robotics. So in this video, this is the Asimo humanoid robot.
To play sports. However, it's wise to warm up before any physical exercise, even if you're a robot. And as well as run at 6 miles an hour, Asimo can walk backwards and hop. It can also kick a ball, so time for a quick robot versus human penalty shootout. That's 1-0 to the Autobots. But is Asimo as good at saving a shot as it is to play?
The next Curiosity rover mission animation. The next video is video for Sophia, humanoid robot. The highly intelligent robot.
Sophia is able to display more than 50 facial expressions. At the Future Investment Summit 2017 in Riyadh, Sophia was granted Saudi Arabian citizenship, making her the first ever robot to ever have a nationality. Wow! It was in the year 2017. Look at her smiling away. It was in November 2017 when Sophia was named the United Nations Development Programme's first ever innovation champion and is the first non-human to be. Sophia is able to display more than 50.
So okay, next video we will discuss about the robot parts and their function. So thank you.